Hello friends, in this session we will be studying about the topic satellite communication, which is from the subject communication and computer networks. It is for electrical and electronics students of diploma. Myself Chetan Shankar Patil, M.Tech Digital Electronics, HOD Electronics and Communication Engineering Department, Jain Polytechnic, Belgavi. So let's begin with the contents. So first it will be introduction, then basics operation of communication satellite, then satellite orbit, geosynchronous orbit, satellite transponder, satellite subsystem, satellite earth station, applications of satellite, global positioning system architecture, then GPS receiver, applications of GPS, differential GPS, and GIS, that is Geographic Information System. So these all we will be covering today. First, the introduction. So what it is? A satellite is a physical object that orbits or revolves around some celestial body, that is nothing but like a solar system. But this we will be dealing about the artificial satellites. So it can be launched into orbit for a variety of purpose, and the major application is the communication. With the help of satellite, it is possible to communicate with any point on the globe. So then next, basic operation of communication satellite. So here you can see in the diagram there is an earth station that it will be transmitting the information to the satellite with a certain frequency called uplink frequency. So from earth station to satellite, it is called as the uplink frequency. For example, they have given over here 6 gigahertz. Then next, the satellite will be containing a receiver which picks up the signal. Then it will transmit the signal, amplify it. How it will be doing? It will receive the signal, picks up the signal, then it will be amplifying the signal, and then it will transfer into other frequency called as downlink frequency and retransmit it back to the receiving station on the earth. So downlink is called nothing but from satellite to the receiving station, that is called as the downlink. Okay, so for here it is nothing but example they have given as 4 gigahertz to. So uplink will be different frequency, downlink will be different frequency. You can see in the diagram. Then next one is what? Satellite orbit. So here orbits, in this satellite orbit, what it is? It is the path in which the satellite revolves around the earth. Okay, so there are 3 orbits: equatorial, polar, and inclined. You can see in the diagram. First one equatorial, in that second one it is polar elliptical, and third one is inclined. Okay, so here in circular orbit, speed of revolution is constant, means it will revolve around the earth in constant speed. The next one, in elliptical orbit, speed changes depending on the height of the satellite. So speed will be changing depending on the height of the satellite above the earth. The next one, we will be seeing about geosynchronous orbit. So here you can see in the diagram there is a geosynchronous, that is satellite orbit. You can see circular and elliptical. Then on top you can see over there, that is nothing but the diagram for geosynchronous. Okay, the choice of the orbit is very important in satellite system design. Most of the communication satellite, they will be using what? Geosynchronous orbit. So that is, the satellite occupies a circular orbit above the equator. So what is the distance at which the satellite will be rotating is 35,784 kilometer above the earth surface. So at this height, the satellite orbit period is equal to what? The time taken by the earth to rotate once, that is in 24 hours it will be. So earth rotation and your satellite rotation will be same. So what will happen? You will find that the satellite is fixed. Whenever you see, it will be at the same position because both the speed are same. Okay. So here the antenna can simply be pointed at the satellite and remains in a fixed position. So your ground station antenna also, it will be at the fixed position. So with this arrangement, continuous communication is possible for entire 24 hours. Okay, in this geosynchronous. The next one, we will be studying about this geosynchronous orbit. Once again, you can see in the diagram the geosynchronous orbit. So here, as I told you, it will be at a distance of about 35,784 kilometers above the Earth's surface. Then it will be rotating with the same speed of the Earth. So you will, whenever you see, that is the satellite will be at the same position. Okay. The next, satellite transponder. So the transmitter and receiver combination in satellite is known as transponder. So what it is? The transmitter and receiving combination, it is called as the transponder. So it is called as satellite transponder, means both receiving and transmitting are there in this. The main function of the transponder is to what? It will amplify, then frequency translation and power amplification. So the block diagram you can see over there. So what all is there? First receiving antenna, then low noise amplifier, then mixer will be there, then your power amplifier will be there, and last there will be a transmitting antenna. So both receiving and transmitting is then, so it is called as the transponder. So here the satellite contains a receiver which picks up transmitted signal of 6 GHz. The output of the receiver is connected to a low noise amplifier. The next, this is given to a mixer. What that mixer will do? The mixer translates signal to another frequency of 4 GHz by heterodyning with the local oscillator of 2 GHz. Then next, the output of the mixer is applied to, what it will be applied? High power amplifier. What it will do? It will increase the signal strength to a suitable level. Then it is then retransmitted to the receiving station by on Earth by transmitting antenna. So that transmitting antenna with another frequency, it will transfer to the Earth station. Okay. So most of the satellite will be having 12 to 24 or more transponder. Each operates at different frequency. Each transponder represents an individual communication channel. Okay. The next one, we will be studying about satellite subsystem. So here is the diagram for your general block diagram for communication satellite. Okay. So the heart of the satellite is what? Communication subsystem. So what all it will be consisting of? First one, power subsystem, then communication subsystem, then antenna subsystem, then telemetry tracking and command control subsystem, and proportional subsystem and attitude control subsystem. So first one in the you can see their power subsystem. So this power subsystem, what it will do? It will give power, means whatever the power has to be given to your satellite will be supplied by the power subsystem. So here solar panels are there because in this space we can't give from power supply from the Earth, so solar panels will be there. So that will be generating. Okay. So that solar power, what it will do, it will be there will be charger and batteries, then regulators will be there for protection, then DC to DC converter, DC to AC converter. Wherever DC is required, the DC is given. Wherever AC is required, there AC will be given. Okay. Then next one, communication subsystem. So here in communication subsystem, what it will be there? The communication subsystem consists of multiple transponders which receives uplink signals, amplify them, then it will be applied to frequency translator, convert it into downlink signal for transmission. This is all it will be done. You can see in the diagram. Then next, antenna subsystem. So all satellites, they will be having one or more antennas. What they will be doing? Either they will be receiving or transmitting the signal, that antennas. The next one is telemetry tracking and command control subsystem. What it will do? It will be monitoring, controlling the conditions of the satellites, such as temperature, battery voltage, etc. Okay. Then next one, propulsion subsystem control and attitude control subsystem. What it will do here, the jet and all means the satellite should revolve, so it has to be given what, jet thrusters, so kick motor, so are the proportional subsystem. What they are do, they are controlled commands from the ground. The attitude control subsystem provides stabilizing in the orbit, so to stabilize the satellite, this proportional will be there. Okay, means to move the satellite. The next, so this is about the satellite subsystem. The next one is satellite earth station. So in this satellite earth station, what it will be there, there will be power subsystem, then antenna subsystem, transmit subsystem, receive subsystem, the ground control equipment, that is called as GCE subsystem. Okay, you can see in the diagram. So same thing, first one, power subsystem, what it will do, it will generate the power, okay, for your satellite. So it can be either AC or DC. There will be a converter, regulator and all. Okay, same as the satellite. Okay, so all satellites, they will be having the same part for power subsystem. The next one, antenna subsystem. Here it consists of parabolic with horn antenna connected at focus point. So it consists of duplexers which help to use same antenna for both transmitting and receiving the signal. So only one antenna is there, that is parabolic dish antenna. The next one, transmit subsystem. The baseband signals such as telephone signals, video, computer data are applied to a multiplexer. So this all, what it is for transmitting, first they will be applied to the multiplexer, all this thing, and that multiplexer, it will take multiple inputs and give one output. Okay, then this IF converted into final output tuned to generate final uplink frequency. So next, receive subsystem, what it will be doing, the signal picked up by the receiving antenna is passed through the band pass filter, then where it will be given to your low noise amplifier, okay, to increase the level of the signal. The low noise amplifier driver a power divider. Okay, then next, it splits the received signal into smaller but equal power signals. Then frequency translation is done in down converter, which is a mixer fed by local oscillator that converts into IF signal. Okay, then the output of band pass filter is applied to ground communication equipment. So this, it consists of what, that ground communication equipment, it consists of demodulator and demultiplexer. What it will do, it will recover the original baseband signal, that it can be voice, video or digital data. Again, it will separate all those things. Okay, so demultiplexer, what it will do, it will take one input and outputs will be more than one, okay, as the original what they have been given. The next one, we will be studying about applications of satellite. So what are the application? First one, communication. Communication is nothing but such as TV broadcasting, telephone, mobile, etc. The next one, for military, it is nothing but for military and defense, not only for communication but also for surveillance and observation about enemies, that it will be done by that satellite. The next, weather monitoring, for predicting of weather conditions it is used. The next one, earth resources. So for what it will be, for identifying forests, lakes, rivers, crops, etc. The next, navigation system. Navigation system is nothing but your global positioning system to provide accurate information and find the position of the moving objects like ships, aircraft, etc. So these are the applications of satellite. The next one, we'll be studying about what it is this global positioning system. Okay, so it is nothing but it is navigation which will helps the user to determine their location, then speed, then time anywhere on the earth in all weather condition. It is officially called as NAVSTAR, that is Navigational Satellite Timing and Ranging. Okay, NAVSTAR. So this global positioning system, it consists of how many? Minimum 30 satellites. It will be consisting of 30 satellites to calculate the position of the individual user. So this GPS, next we will be studying about global positioning system architecture. So what all it will be consisting of? Space segment, control segment and user segment. So here space segment, the space segment of GPS consists of how much? 24 satellites. Up you can see all the satellites. So it will be 24 NAVSTAR satellites. Then here the orbit at an altitude of, it will be placed at an altitude of 20,200 kilometers above the Earth's surface in 6 orbital planes with a period of 12 hours each. It will be. These planes are such that from any location on the Earth, at least you can see 5 satellites. So from any location, they up above us, there will be 5 satellites GPS. Okay. They operate in L1 frequency band, that is 15,742 gigahertz, and continuously broadcast navigational signals. Okay. Then next is your control segment. So your control segment, what it will be? The overall your system performance and accuracy is by the control system. What it will do? It will track the GPS satellites, updates orbiting position, where it is revolving, where it is, calibrates and synchronizes the clocks. So what all it will be consisting of? Master control station, monitor station and ground antenna. So first one, master control station. For master control station, it is only one, that is it is located at Falcon Air Base in Colorado Springs in US, and a number of smaller Earth stations are located at different places of the Earth. Okay. Then it is what? It is responsible for overall management of remote monitoring and transmission sites. Okay. The next one is what? Monitor station. There are totally 5 monitoring stations in the world. What is this? It is used to check or track the exact altitude, position, speed and overall health of the orbiting satellite. Okay. The next one is ground antenna. So here ground antenna is nothing but what it is? It will monitor and track the satellite and transmit correction information to the individual satellite. Okay. The next one is user segment. User segment is nothing but it can be the devices which we are using, which there will be a GPS, either it will be in your vehicle or in your mobile and all, that is nothing but your user segment. So what it will be doing, consisting of, it will be consisting of antenna, then receiver, processor, a high stable clock, then next display, a display for showing information to the user. Okay. Then next is GPS receiver will be studying. So here you can see the GPS receiver. It is a microprocessor based system. So along with a multi-channel satellite receiver which receives the signal from what? NAVSTAR satellite visible at the location. So this GPS receiver is nothing but which device will be having with us, that is GPS device. So what all it will be having in it? It will be having preamplifier, multi-channel satellite receiver, microprocessor, then application software will be there and display will be there. Okay. The GPS system consists of how much? I have told you, 24 satellites in different orbit around the Earth. 4 satellites are used in each orbit with 6 orbits totally. The data sent by each satellite is known as almanac, consists of coded time and location of the satellite. The GPS receiver calculates its own location parameters from a minimum of 4 such signals. Then the location data can be combined with application software package such as mapping software. Okay. So you will be having no Google Maps and all that one. Okay. That is the application software. The next one, what are the applications of GPS will be studying. So first one, it is used in gadgets available in what? Many cars, cellular phones and digital watches. Then second one, navigation of vehicles on land, sea and air it is used. Then for surveying, then remote sensing, accident relief operation by traffic police, that you can see on the GPS wherever the traffic and all is there, then it will be marked. Okay, the next, ambulance service for hospitals, military application for tracking vehicles, tankers movements and target identification, then offering safety and security operation. So these are all the applications of GPS. The next one we will be studying about differential GPS. So here it is the advanced version of GPS which gives better accuracy in the location. In normal GPS, accuracy will be 15 meters, and in differential GPS, accuracy will be up to 10 centimeter is achieved. Okay, so here in normal GPS there may be errors in radio signals which travels from satellite to Earth through atmosphere may slow down while passing through the ionosphere and troposphere regions. So this results in errors. So this is corrected by what? Your GPS, differential GPS. So a differential GPS receiver is fitted to all the user consist on FM receiver in addition to GPS receiver. So figure you can see over there what all it will be having. A FM receiver receives the signal first from the FM transmitted located at DGPS, that is differential GPS base station called as reference station. It is stationary station whose longitude, latitude and altitude is known. Okay, then GPS receiver receives signal from GPS satellite. The reference station receives GPS signal and computes its location parameter. The next what will happen? These parameters are compared with its own known location parameters to calculate error of the GPS receiver. So your FM and your GPS they will be comparing and you will getting the output. The error calculated is called differential error. So whatever the error will be there, that it is called as what? Differential error. This station after making correction, what it will do? It will broadcast to all your differential GPS receiver around the reference station using FM transmitter. It will be transmitted. Okay, you can see over there in the diagram. So here this differential GPS receiver obtains location parameters from GPS data, then applies correction based on the information received by the FM channel. Then this technology receiver locates the transmission of at least 4 satellites. Okay, then information of these 4 satellites in order to know the exact location. Then next, with differential GPS, corrections are made and this results in obtaining more accurate location parameter. As I told you in simple word, the FM channel and your GPS both it will be receiving, then the comparison will take place, then whatever the error is removed, and then after correcting you will get your differential GPS. Okay, so like that it will be. Got it? Okay, the next one is what? Geographic information system. So what is this geographic information system? It is nothing but computerized system for capable of storing, manipulating, analyzing and displaying all kind of geographical data. So geographic information system it is. All kind of geographical data it will be doing, that is surveying and all. Okay, so what is the concept of this? GIS system is an image to give what is present on the earth. So you can see from your this Google Maps, all the images where means where is your home and all those images you will be getting. So this it will be nothing but your this one, geographic information system, that is surveying and all. Okay, the GIS user can take the data from the map to know how much for example to know how much the forest area is on the land, etc. Then advantages of GIS. What are the advantages? GIS usage is vast. GIS provides a platform to update geographical data without wasting time and visit the field and update database manually. The next one, applications of GIS. For what it will be used? For disaster management, that is in the case of earthquakes, floods, cyclones, etc. The next, for town planning. So that is usage of land properly, transportation management, efficient water supply, irrigation, pollution control, waste management, so can be planned by implementing this thing. Okay, the next one, agriculture. Depending on water availability and irrigation, proper crops can be grown. Okay, then natural resource management can also be done using GIS. Then that is resources. Then development plans, maps, areas can be prepared as required to any scale. The next one, proper resource utilization and management planning is done through GIS. The next one, impact of future effects of certain development and decisions can be accessed in advance by using this GIS. So these are all the applications. Okay, then by this we will be completing this fourth chapter. Thank you.